good. Everyone is fine. So we are back with the next session for the rapid revision session. That is the chapter chemical bonding and molecular structure. So I hope everyone you know that it is how much important this chapter is. It is very important chapter. I can say without any doubt it is the most important chapter in the whole chemistry. The reason being that because it is going to be used everywhere, be it inorganic, organic, physical, everywhere for sure. Because we have to deal with the molecules, and in the molecule you have to know the structures, and the structures is all told by this chapter. Then it comes to organic, everywhere. If you are going to study about GOC, if you are going to talk about bond fission or mechanism, everywhere you have to know many of the things or many of the facts that we are going to study here. If you are talking about physical chemistry, if you go to redox reaction, I think you all know that if you are going to solve many of the question where you have to tell about the oxidation states and these things, I hope you know. There you need to know how the bonds will be broken and how the electrons will be, you can say polarized towards which atom. So these things, all the things are given by this single chapter. So this chapter, first of all, has a very important basic perspective, and second thing is that it is going to be very important if the number of question is concerned, because every year, if not more, then at least 3 to 4 question comes. At least I'm saying it may go up to 6 also. As you can see in the previous year's question, there have been years where the 6 question have come from the same chapter. So it tells you the story that it's a very important chapter. So let's start this very important chapter. The name is chemical bonding. So Zara think about, I will not go much to the theories today because it's a very big chapter. We take at least 15 days if we are going very fast, and otherwise so it may take even more time. So if we are trying to complete it in just one session, so of course the speed is of very much essence, so we have to be in speed. And one message to those students who are asking me question during this session, please, I can really not answer in this time, because you know that I have to be fast. I have to complete all the questions, right, and all the content. So that's why I cannot. Sorry for that. But yeah, one more thing I will tell you. If you have the question after the session is completed, put your question by putting the timeline, tag the timeline in the comment, and please ask the question. I will check that. Whatever is the doubt, I will answer you later on, not during the session. The reason is I hope you all know about it. So what is chemical bonding? Let's start with that. Chemical bonding. Let's think of it. What do we study in chemistry? In chemistry, we study about chemicals or chemical reaction. In chemistry, basically, what are the things we are going to mainly study about? We are going to study about chemical reaction. Chemical reaction. What is chemical reaction? Can anybody tell me? Chemical reaction is nothing but breaking and making of bond. Breaking and making of bonds. Acha, what is bonds? Now the question comes, what is bond? Now bond is nothing but it is attraction force between the atoms or the ions, or you can say any of the constituent of any molecules. So what we can say? Attraction force between the constituents of a molecule. This may be atom, ions, etc. Right? So these things it may be. Now, here comes that now that on the basis of which kind of bond is there or how that bond is formed, there are many ways of formation of bond are there, and many types of bonds are there. I hope I'm considering, because it's a revision session, I hope everything is theoretically clear. But still, I will be telling everything. I will try to go as much in detail as possible during solving question. Okay, so let's start with the question without wasting time. Introduction. I hope we already have seen that. What are these introductions? These are something about the chemical bonding. So chemical bonding, force of attraction. We all know, you can say that force of Force of attraction between atoms. We can say atoms or ions, right? Not an issue, right? But just just on surface it is the definition, it is not the complete definition. Now why the bonding even takes place, and what is the need? Just think about it. When the ions or atoms are there in the free state, they are very much reactive. Now if they are reactive, are they stable? No, not at all. Kinetically they are very unstable. So to have them thermodynamic and kinetic stability, they have to be bonded. Once they bond and they form the molecules, what will happen? I hope you understand. These atoms or atoms which were free and having very high energy and less stability, once they get bonded, their stability become high and energy become less. So in such case, what happens? They gain the stability. So if someone asks you why, what is the need? So I hope you all understand. To gain stability. So in one word, if someone asks you what is the need of bonding, so you already and always can say that the main answer is to gain stability. Now reasons to form chemical bonding, here everything is given. The main reason I have already told you, to acquire the noble gas or nearest noble gas configuration. Though this is not the complete answer, but it was the initial theories which were proposed, right? Next, to decrease the energy of the system. Of course, if once the energy of the system will increase, stability, or we can say stability will, to achieve the stability and to decrease the reactivity. So these are the main reasons why the chemical bonding takes place. Now chemical bonding have two types. One is strong bonds, another is weak bond. What are the strong bonds? Strong bonds are those bonds which are between the ions or the atoms. Now these are, you can see 3-4 types of bonds are there. If you remove metallic bond, there will be 3, otherwise 4. One is, I hope everyone you know the mother of all the chemical bonds, that is covalent bond, then ionic bond, then coordinate bond, and last one will be metallic bond. And in weak forces, it is not between the atoms, but these are intermolecular forces. What are intermolecular forces? Those force of attraction which are between the molecules. And what are those? I hope you know that van der Waals forces and hydrogen bonding. Their strength is less, their strength is more. That's why they are strong bond, while these are weak bonds. Okay, let's go to the next point. Chemical bonding theories. There are called Coastal-Lewis approach. What is the Coastal and Lewis approach? That is only that every atom is trying to achieve the nearest noble gas electronic configuration. So basically it was nothing but approach to or nearest noble gas electronic configuration. Of course, every atom is trying to achieve this. So achievement of the nearest noble gas electronic configuration. Valence bond theory. But we saw that there are few. So basically octet once, and then it converts into octet rule. What is octet rule? Because we know that in all the noble gases, their octet is complete. Yes or no? NS2, NP6. So NS2, 2 electron, and P may how many electrons? 6. So 2 plus 6 is how much? 8. So how many of the electrons? We can see that in the valence shell it is completing 8. So what we can say that it is nothing but it is trying to indirectly it is trying to say that every atom tries to complete its octet. But there were many exceptions. What are those exceptions? Can anybody tell me? Please remember. There are few. Remember them. See, one is going to be those molecules which are hypovalent atoms. What? BeCl2, or what we can say that BCl3, right? So these are the examples. I hope you can see that here beryllium has, you can see beryllium is having 2 electrons of itself, and how many electrons it is coming from chlorine? 1. So how many electrons are coming? 4. So octet is not being completed. Think about BCl3 also. I hope you can see that here it is going to be boron is having 3 and 3 it is getting, so 6. So hypovalent. Next is hypervalent. What is hypervalent? Hypervalent, or we can say that it is nothing but jahan pe octet is extended or expanded octet molecules. What are those? I hope you all know these examples very well. Like, I hope you know that PCl5. Arey, sabko pata hai, yes or no? Then I hope you know that SF4, SF6, these things. Everyone, yes or no? Yes. Next, what else? Like, see, those elements or those molecules where there is non-noble gas electronic configuration is achieved. Like what we can say, I hope you know that Sn plus 2, Zn plus 2. You can see that they do not have the noble gas electronic configuration. Still they are stable, yes or no? And if they are stable, what we can say? They all are what? They all are non-noble gas electronic configuration. These are the molecules. There are even more, like what we can see, because it is telling, and it used to say that noble gases are non-reactive. That's why other elements want to be like them, because they are non-reactive, so they are stable. But we see that xenon and krypton can form bonds, so it is breaking the whole basis of the Coastal-Lewis approach. That was what I think you all know, that XeO2 F2, XeF6, XeO3. There are not many examples are there. So I hope you understand how these examples are backing this octet rule. These are the exceptions. Next, let's talk about the valence bond theory. The valence bond theory says that it is talking about basically covalent bond. So covalent bond is formed by the overlap of the atomic orbital, and these are going to be pure atomic orbitals. So any of the element is going to be, or any of the bond is going to be formed by the overlap of the atomic orbitals. But these atomic orbitals, or what we can say, that when they are going to form the bond, when they have the unpaired electrons. So whatever is the number of unpaired electron will be there, the same number of bonds they can form. So what we can say, number of covalency. So whatever is the number of bond they are going to form, it is going to be equal to the covalency. So covalency is nothing but it is equal to the number of unpaired electron, either in its ground state or in its excited state. They even may increase their valency by going into excited state, right? So these are the few things that was told by valence bond theory. Of course, valence bond theory is very, very beautiful theory. There are many intricacies are there in valence bond theory, and because it has talked about how the pi bonds are formed, sigma bonds are formed, that we'll see in the question solving. So this is about the VBT theory. That is going to be one of the very important. And after that, just with the few changes in VBT, the next that was very, very important theory came out to be, that was hybridization. So after VBT, hybridization, you can say the hybridization is kid, or you can say son of VBT, valence bond theory. But hybridization came up with many of the changes into it, and those changes, whatever were the problems that VBT could not explain, that was explained by hybridization. Like we will see that, I will tell you the example of methane later on when we will be talking about the questions. Then VSEPR. See, once we are talking about hybridization was very good theory for those kind of substances where everything was cool, the number of, there is not going to be any lone pair. It was very good. By that time it was okay. Whatever is bond angle, bond length, everything was okay, cool. But once Vesper theory, what is that Vesper theory? We'll talk about that. Valence shell electron pair repulsion theory. When there are many of the molecules, when there is lone pair available on the central atom, then the whole molecule's structure was changing. Basically, the molecular geometry and electrical geometry, there are two different types of geometries. We will talk about electronic geometry is the same. That we'll find out with the help of hybridization only. Hybridization can be found out with the help of, one thing I would like to tell you here only with the regarding hybridization. Hybridization, I hope you all know that it is given by steric number. Steric number, what we can say? Sn. Steric number, I hope you know that if steric number is 2, then hybridization is what? Sp. If steric number is 3, then it is Sp2. If it is 4, then it is Sp3. If it is 5, it is Sp3d. If it is 6, then it is Sp3d2. If it is 7, Sp3d3. So this is something that I hope you all know about it. Sp is nothing but it is linear. Sp2 is what? Trigonal planar. Sp3 is what? Tetrahedral. Sp3d is what? Trigonal bipyramidal. Sp3d2 is octahedral or square planar bipyramidal. It is what? Pentagonal bipyramidal. Yes or no? So these are the structures, what it shows, when there is no lone pair. But once the lone pair starts coming, the whole structure changes. I hope this is something that we have already studied in VSEPR. We have seen the tables. This table is available in every book, everywhere. Everyone have studied about this. Now, this was something that was about the VSEPR, and then we are going to talk about molecular orbital theory. See, molecular orbital theory is such a beautiful theory that chemistry has not seen a better approach than molecular orbital theory to explain anything about anything. You know, in any of the molecule, if you are trying to find out, or if you are trying to compare the bond strength, bond length, everything, molecular orbital theory is there. Even if it is by diatomic, polyatomic, for everything, molecular orbital theory is there. It is very good. But VBT was, or where we are going to use VBT in our question solving, we'll see that whenever there is, you know, bond strength of sigma, sigma comparison, pi, pi comparison, these kind of questions, whenever there will be coming, VBT will come here. Now, hybridization comes for if there is polyatomic species, but VBT was there only for the, you know, diatomic species work very well. For hybridization, what we are going to take? Polyatomic species. And but hybridization had a problem that it only concerns about the central atom, not things about the, you know, side atom. I hope whatever I'm saying you, so these things you all don't know that it is just the revision purpose. But when it comes to molecular orbital theory, it talks about everything, the side atom as well as the central atom. So it is like, it is, you know, all-rounder kind of theory. Everything can be explained with the help of molecular orbital theory. It is based on, you know, modern physics, or you can say quantum mechanical approach, that we are going to talk about later on. Here again, directly go to the question without wasting time. Draw the best Lewis dot structure for each of the following species. See, let me tell you, this is Lewis dot structure is generally, you can make it best for what? For those molecules which follow octet rule. But still you can follow them, you can go with them also. BF3, does it follow octet rule? No. Octet rule not followed, but still you can see that. What you have to do here, always remember, valence electrons. How many of the valence electron are there? Beryllium has 2, fluorine has 7. 7 to the, how much it is there? 7 to the 14. 14 plus 2, how many total valence electrons are there? 16 electrons are there. Always do one thing, that whatever is the central atom, write it down. Whatever is the side atom, note it down. How are you going to write these central atoms or side atoms? Side atoms should always be written in a, you know, symmetrical way, because if there is beryllium, so there will be fluorine, and always make a single bond between this side atom and central atom. So how many of the electron has already used? 4. Out of 16 electron, 4 electrons are already used. How many electrons removed? Remaining. So remaining are 12. So first of all, give these 12 electrons to the side atoms to complete their octet. Once we have given, there is no electron left for beryllium, so beryllium will have no electron here. Okay, so this is something, that is how you can make the beryllium fluoride. And what about BCl3? I am making it faster. Cl, tune. Done. What about that? CCl4 here also octet rule, here also octet rule not being followed. CCl4, here octet rule is being followed. How are you going to make it? Of course, just think about it. C, carbon, think about it. Carbon is having 4, fluorine is having 7. 7 for the 28. So how much it is? 32. Just write C, and then C, Cl. Then what you do? Make 1 bond. And for every bond, how many of the electrons are used? 2. So how many electrons are already used? 8. How many remaining? 24. These are the remaining electrons. So give, because we see that chlorine has already, all the chlorine has 2 electrons. So how many electron extra they need to complete their octet? 6. Now give them 6. How many we can see that it is already completed, and how many we had? 24. So we have given 6 4s are 24. All the electrons are already given. Can you see carbon? Because you can see that every bond, it is forming 4 bonds, so it has already completed its octet. So not a big deal, it has already completed. Here it is extended octet. Extended octet means octet rule here also not followed. What we can say? P, then just make Br. Here, of course, bromine, to all the bromines are following octet rule. But phosphorus, can you see how many of the bonds it is forming? 5 bonds. So 5 bonds is equivalent to 10 electrons. So here phosphorus is going to be expanded octet. I hope you all understand that is how you can make the Lewis dot structure. Whatever the rule I have told you, please follow those steps. You can make easily. Which is not an exception to octet rule. I hope you all can see that very fast. BF3, it is an exception. SnCl4, yes, it is not. Why? Because Sn has 4 electron. How many extra it is coming? From every carbon it is coming, taking 1, 1, 1. So how many chlorines are there? It is taking 1, 1 from chlorine. So every how many chlorines are there? 4. So how many of the electrons are there going to be? 8. Perfect. Of course. BeI2, no. PCl5, no. Extended. So B, option B, easy. Next, which of the following cannot exhibit covalency more than 4? Always remember few rules. It is from the valence bond theory. Valence bond theory. Few rules you have to keep in mind. Second period element due to unavailability of vacant d orbital of required energy, or you can say lower energy level, lower energy, what we can say, cannot expand its octet. What we can say, second period, in second period how many? 2s 2p. So 2s has 2 electron, 2p has how many orbitals? 3 orbitals. 2s has 1 orbital. So how many? 4 orbitals are there. So because they cannot expand their octet, so because to expand their octet they need to go to higher energy level, that is in the third shell. That will just make it energetically very unstable. That's why people say that there is unavailability of d orbital. No, it's not. It's a wrong concept. But the thing is, the d orbital is there, but it is of the very high energy level. But if you take electron in 3d orbital, it will be of very high energy and it will make the whole molecule very unstable. So even though it is written in NCERT also, so please go with that line, no problem. So because of the unavailability of the d orbital, that is also okay. What happens? They cannot expand their octet. Therefore, maximum covalency, maximum covalency comes out to be 4, and maximum coordination number also comes out to be 4. What is covalency? The covalency is the number of bonds that any atom can form. What is coordination number? Coordination number is equal to the number of elements or side atoms that it can have around the central atom. Okay, but what about the third period element? What about third period element? Because generally we only see that third and second and third only. Third period element, maximum covalency, we have seen that it can go even up to 7, but maximum coordination number can only go up to 6. It cannot exceed more than 6. No. So of course covalency, it can make 7 bonds, but the thing is number of elements or side atoms that it will hold only 6. Understanding it? I hope it is very clear. So here, which cannot exhibit covalency more than 4? Who cannot exhibit more than 4? Who are from the second period. Who are from the second period? This is from the third period. This is from the, I think, boron and nitrogen from second period. So option B is the correct option. Okay, not an issue. Next, calculate the formal charge on the central oxygen atom on O3. Now for that you need to make the, yes, Lewis dot structure. So how many oxygens are there? 3 oxygens are there. 3 oxygen has how many electrons? Valence electrons. Valence electrons is going to be 6 3s are 18. Okay, make that. First of all, make the 1 1 bond. How many of the electrons are consumed? 4. Minus 4, do it. How many remaining? It is 14 electrons. Still it is remaining. Remaining. If it is remaining, so just first of all complete the octet of side atom. Side atom completed its octet. Yes or no? Still how many electrons used? Only 6 6 12. Still there are 2 electrons remaining. So it will be given to the central atom. Can you see that this has a completed octet, but it has not completed octet? Always make sure that you are completing the central atom's octet. If you are trying to find out the formal charge, try to do that. If you are trying to do that, either it will take from this oxygen or it will take from this oxygen. These lone pairs. Once it takes the lone pair from this, how it will be looking like? O, double bond O, single bond O. What will happen? It will be looking something like that. But what will be the formal charge? So formal charge is given by a formal charge. How do we find out? It is equals to whatever is the what to say, valence electrons are there minus non-bonded electrons, V minus N, minus bonded electrons divided by 2. So bonded, or we can directly say minus of bond. Minus of bond is okay, not an issue. Can just go with that. Minus number of bonds. So can you see about this oxygen? This oxygen, how many of the electrons are there? Can you see? How many of the electron is there? Can you see? How many of the electrons? Can you see? Let's talk about this oxygen. If you are talking about this oxygen, how many of the covalent valence electrons are there? 6, minus how many of the non-bonded electrons are there? Can you see? 6. So 6 minus 6, minus of whatever the number of bonds. How many number of bonds it is forming? 1. So minus 1. So 6 minus 6 minus 1. So what is the formal charge? Formal charge on this oxygen comes out to be, I hope you can see that this oxygen is having minus 1. What about this one, this oxygen? Can you see? This is having how many of the, see, oxygen has 6 valence electron, minus how many of the non-bonded electrons are there? Can you see? Only 2 non-bonded. Whatever is the lone pair, that is nothing but non-bonded electron. How many of the bonds are there? 3. 1, 2, 3. So can you see it is how much? Plus 1. So this oxygen has the oxidation number plus 1, while this one was having minus 1. Can you see this oxygen? This oxygen is nothing but, can you see, there are 6 minus how many of the bonded non-bonded electrons are there? 4, minus how many bonds are there? 2, that is equals to 0. So this oxygen has the you can see formal charge 0. So in this one, middle one plus 1, side one minus 1. As a rule, remember, if any atom is making more than it, oxygen can make generally 2 bonds, but if it is making 3, so make plus 1. If it is making less than 1, let's say 2, it can make, but if it is making 1, so it will have minus 1. It's a very simple thing, right? Because this oxygen has made 3 bonds, but it could make only 2 bonds, so give plus 1. This oxygen could make 2 bonds, but it is making only 1 bond, so give minus 1. This oxygen could make 2 bonds, making 2 bonds, so no formal charge. Is it okay or not? I hope so. So it is asking for the central atom. Central oxygen has plus 1. Plus 1 is the option B. I think it is very okay and very clear to all of you. Next, we are going to the dipole moments is 0n. See, dipole moments. What is dipole moment? First of all, you have to remember dipole moment is nothing but it is a dipole moment. Mu is a vector quantity. It is what? Vector quantity, and it is given by mu equals to Q into D. Q is what? Charge on any atom multiplied by D. D is nothing but distance. Distance what? Internuclear distance. Okay. So this is what? Q into D. What is the unit? Unit generally, these are the questions that may be asked. So unit is nothing but, we use unit as debye. Achha, what is debye equal to? 1 debye is nothing but it is equals to 10 to the power minus 18 ESU centimeter. And it is also equal to, if you are trying to find out in Coulomb meter, that is SI unit. If you are thinking of SI unit, it is nothing but Coulomb meter, because charge has the unit Coulomb and D has the distance as the meter. So what is that? It is 3.33 into 10 to the power minus 30 Coulomb meter. Can you see that? Very easy, right? Not a big deal. Now, how to find out? And see, there are lot many molecules are there. See, diatomic, polyatomic. So in this case, always we have to go as a rule. This is from in chemistry, not in physics. So dipole moment shown by tailed arrow like that, from less electronegative to more electronegative atom. If all the dipole moments are going to be cancelled, so mu will be equal to 0. That is the rule. And always remember the direction of mu is always from central atom to lone pair. If the lone pair is there on the atom, it will be always going from central atom to lone pair as a rule. And never ever try to cancel the lone pair dipole moment is known as atomic dipole, and whatever is bonded dipole, it is called bond dipole. Bond dipole can never cancel atomic dipole as a rule. So lone pair, if there is some dipole due to lone pair, it can never be cancelled by a bonded dipoles. No, never. Chalo bhai, think about NH3, N H H H, and there is lone pair. Can you see it? So nitrogen to lone pair, hydrogen to nitrogen, hydrogen to nitrogen, hydrogen to nitrogen. Can you see all these mu will be added and mu will be non-zero for it. NF3. What about this N lone pair F F F? So here fluorine is going to what? Take the lone pairs, dipole moment towards it, but this is going to be one lone pair upwards. So this mu, consider mu net is there something mu 2, and there it is mu 1. Mu 1, mu 2 can never cancel. I told you right now only the rule that it can never cancel. Atomic dipole and bonded dipole can never be cancelled. So it will also have mu non-zero. SO2, SO3, SO3, think about it. SO3, I'm directly telling you what is that? So SO3 has sp2 hybridization. How did I find out? I think you all know that. How to find out steric number? Steric number equals to half of V plus M minus C plus A. Can you see? V is nothing but whatever is the valence electron. M is the monovalent atoms. Is there any monovalent atom inside? No. Oxygen is divalent, so do not count it. Minus C means minus of whatever is positive charge, plus A. A means nothing but negative charge. Is there any positive or negative charge? No. What we can say? Half of whatever is the valence electrons on sulfur 6. It is how 3. 3 is nothing but steric number 3 is for sp2 rule. So sp2, if it is sp2, what it should be? It should be trigonal planar. S double bond O, double bond O, double bond O. So what we can say? Can you see all of these are symmetrical? Symmetrical. And if they symmetrical, all of them will be cancelled by each other. Can you see 120 degrees? There will be mu in this side. Both of the mu's will be cancelled by each other. So SO3 is what? It is a, you can say here mu is equal to 0, because it is a, or whenever there is symmetrical element molecule, so there the mu is going to be 0 as a rule. Direct kar sakte ho yaar. Next, in which of the following molecule dipole moment is more than 0 but less than 1? Okay, more than 0 but less than. Can you see N lone pair H H H? तो यहाँ पर क्या हो रहा है? That there is going to be mu here also upward, and this lone pair is also upward. So here, let's say it is mu 1, let's say it is mu 2. Both of them are being added. So they are going to be more than 1. Mu 1, mu 2 more than 1. Because though two dipole moments are in the same side. Here talk about NF3. N, F, 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 and there is lone pair. What will happen? Can you see that here? One is upside, but another is downside. So can you see whatever the mu net consider, it is mu net is mu 2, and one mu 1 is upside. So can you see mu 1 going upside, mu 2 coming downside. So what will happen? The overall mu will be less than 1. Of course it will be more than 0 because it is non-zero, but it will be less than 1 because it is going to be cancelling both the each other. So NF3 is the correct option. देखना PYQ है. Find out correct order of dipole moment. Correct order of dipole moment. Can you see SO2 equals to CO2? SO2 के बारे में बात करो. It is what? It is again sp2. So थोड़ा बहुत तो whisper सबको आता है. I hope you all can see that here it is going to be something like that. What we can see. So there is going to be mu 1, mu 2. No, because CO2. If you talk about C, so here mu is non-zero in SO2, while in CO2 mu is going to be 0. The reason being carbon to oxygen, both of them are going to be cancelling each other. No, it is wrong. Next, BF3 equals to BeCl2 is equals to XCF2. Can you see BF3 is a, yes, it is symmetrical. Correct है. BeCl2 symmetrical. Correct है. What about XCF2? XCF2 के लिए थोड़ा देखना पड़ेगा. XCF2 is nothing but you have to find out what is the hybridization. Hybridization comes out to be sp3d. sp3d. How it is coming? Because xenon has how many of the valence electrons? I hope you know that. 8. How many of the monovalent electron elements are there? 2. So half of 10 is equals to 5, and 5 stands for sp3d, and it is for trigonal bipyramidal. Trigonal bipyramidal. If you are thinking like that, XC, all the lone pair always take the equatorial position, never the axial position if they have the possibility. So these will take the equatorial positions, while axial पे कौन जाएगा? Fluorine, fluorine. These fluorine are going to cancel each other, and these lone pairs are going to cancel each other because they are symmetrically available there. So what we can say here also, it is equals to mu equals to 0. So all of them has the mu equal to 0. Option B is the correct option. Next, dipole moment for this is 1.5d. The dipole moment for this is, okay, cancel, x cancel. Can you see? But outside. Why? Carbon to halogen. Carbon to halogen is going to be, halogen is going to be more electronegative. So what we can say? How much is the, this angle? This angle is 120 degree. You know that whenever there is, consider 120 degree is there, mu 1, and it is also mu 1, or you can say mu. What we can say? The resultant that comes to be, it is also, it is by the rule of, vector. You know that the resultant will also be equal to mu, right? So this will be, the resultant of this will also be equal to what? Mu. If upwards it is mu, upward to it is already cancelled. So overall it will be equal to mu only. Achha, how much was this? It was 1.5d. So it will also be 1.5d. D is nothing but device. So only option A. Not a big deal. Easy, right? Which of the following is not correct for dipole moment? चलिए आइए. Lone pairs of electrons present on the central atom can give rise to dipole moment. हाँ भाई बिल्कुल सही बात है. The dipole moment is a vector quantity. Yes, CO2 molecule has no dipole moment since CO bonds are non-polar. No, CO bonds are polar, but still it is non-polar. Reason being that they cancel each other. So option C is the correct, because of course this is correct, but this is wrong statement. Next, here we have come to the next question, that is, just a minute class. Okay, so now the dipole moment of HBr is this much, coulomb meter. The interatomic spacing is this much. The percentage of ionic character. See, whenever there is dipole moment has many types of question. They will ask you a question like, is the molecule polar or non-polar? One kind of question, we have solved it, not many. Next, what is the percentage ionic character? Let me tell you, how do you find out? In ionic molecule, you know that in ionic molecule, charges are complete. Charges are unit, are complete. Complete means nothing but either 1 electron, 2 electron, 3 electron. I hope you understand it. 1 electron has how much of charge? I hope you know that. 1 electron, 2 electronic, 3 electronic charge. So let's find out. HBr. It is, we expect that H is going to be +1 and Br is going to be -1. And -1 is nothing but, it is equals to how much of that? 1.6 into 10 to the power -19 coulomb. So we are expecting, if it is ionic, if it is 100% ionic, if 100% ionic, if 100% ionic, but it is not 100% ionic. Let's find out how. Because we know that mu equals to Q into D. What is mu given? Is the mu given? Dipole moment is given 2.6 into 10 to the power -30 equals to, what is the charge? Acha, charge it is asking. Charge, that is, we are going to be charge practical, or we can say experimental charge multiplied by, what is the D distance? It is 1.41. It is given in angstrom. Can you convert it into meter? 10 to the power -10 meter into 10 to the power -10 meter. So this is what, this is, from here you can find out Q experimental. Let's find out Q. Some Q experimental you will get, consider the value is X. I do not know, you can do it. Q experimental you can find out this, some amount of coulomb will be there. Whatever the coulomb you get, what you will do? You will do percentage ionic character equals to Q experimental divided by Q, whatever is theoretical. Theoretically, how much it should be? Theoretically should be 1.6. Whatever is this, it is considered X by 1.6 into 10 to the power -19 multiplied by 100. You can do that and you can get the answer. I hope it is B option. You can just check that. Next, find the correct order of covalent character in the following. Now understand it how, from where this question is coming. Please remember one thing, that is called Fajan's rule. Once the dipole moment comes, Fajan's rule comes into the picture. What is Fajan's rule? I will not go very much into depth, just because of there are a lot many important points still to be covered. See, Fajan's rule or Fayance rule. Fayance rule, it says directly, I am telling you, Fayance rule. It deals with for those molecules which are ionic, which are expected to be ionic, but they have some covalent character, because I have already told you every molecule is neither completely ionic, neither completely covalent. It has, of course, maybe completely covalent if it is a non-polar covalent bond. But if there is any ionic, it is never the complete 100% ionic. So that whatever is the percentage of covalent character, that we can find out with the help of Fajan's rule. How and what does this Fajan's rule says? Covalent character is directly proportional to polarization, and polarization is directly proportional to charge on cation and anion. Consider anion is A minus, cation is C plus, and but inversely proportional to size of cation, but directly proportional to size of anion. There is a beautiful explanation to it, that how the polarization takes place, how cation being small attracts the electron, density of the anion, and how that gets polarized, and how the deformation of the electron density takes place. It's a complete, I hope everyone you know that. On that basis, I'm just writing those things, and everyone we know that the more the covalent character will be there, percentage covalent character will be there. We can say that, and we know that percentage covalent character will be inversely proportional to percentage ionic character. So more the covalent character will be there, lesser the ionic character will be there, as a rule. Should I? So okay, what it is asking for? It is asking for covalent character. Chalo bhai, socha jaye. So can you see NaCl, MgCl2, Na plus, here see all the negative, and ion is same. So let's talk about the cation. It is what? +1. It is what? +2. So if it is there, Na and Mg, both of them are from the same period. If they are from the same period, do not think of the size. Think about the charge. Can you think of the charge? The covalent character is inversely proportional to, directly proportional to charge. Okay, directly proportional to charge on cation. Can you see? More charge means there will be more covalency, but it is giving less covalency, so it is wrong. Next, AgCl, AgF. Think about it. Ag is here same, Ag plus 1. Here Cl is what? Cl is of third period, while F is from second period. So fluoride is a smaller, but chloride is a bigger. What we can say? Covalent character is directly proportional to size of anion. So more chloride is larger, so therefore it should have a more covalent character, should be more, but it is given wrong, so it is wrong. NaCl more than zinc chloride, wrong. Why? On one more thing, please keep in mind. Polarization is directly proportional to non-noble gas electronic configuration, like zinc +2 Sn +2 Sn +4. These things are going to be, or you can see Cu +2. These are going to have, more, or Cu +1, whatever you take. Cu +1. If you compare Cu +1 with K+, no. Cu+ is going to be more covalent than K+. The reason being, again, here comes the Z effective, and all those things are there. How? Because of the presence of d subshells on those electrons contract the copper, and that makes the smaller, and Z effective increases. Because of that, it starts, doing the polarization even more. So these are the reasons why zinc +2, or we can say non-noble gas electronic configuration, have higher polarization. If higher polarization, we can say more covalent character. So NaCl will have, less. It will have less, while it will have more. It is also wrong, maybe. Then okay, then calcium chloride and cadmium chloride for sure, because cadmium is what? We can see that it is also non-noble gas electronic configuration. So of course this will have more covalent character. So option D is the correct option. Very important. Which of the following alkaline earth metal halide gives below essentially covalent in nature? चलिए जरा देखते हैं. SrCl2. What is same? Here anions are same. So think about it. +2 charges are also same. We all know that covalent character is inversely proportional to size of cation. Can you see where the size is more? Where the size, or we can, what it is asking for? Essentially covalent in nature means we need smaller cation. Smaller cation will give, if smaller cation will be there, more covalent character will be there. Okay, so beryllium chloride will be the correct option. I hope it is very clear. Next, lithium chloride, RbCl, BeCl2, MgCl2, the compound with the greatest and least ionic character. Ionic character is inversely proportional to covalent character. And covalent character, I hope you can see that all of them are chloride. So covalent character is directly inversely proportional to size, but directly proportional to charge. Charge on cation. I'm talking only about cations. Think about it. Li कहाँ पे सबसे छोटा? If the smallest is there, but charge is highest. Smallest and highest charge. Smallest size but highest charge. Beryllium plus 2. Beryllium plus 2 being smallest with highest charge. Highest charge. If it is there, so what we can say? It is most covalent. Think about what out of all these, lithium, rubidium, beryllium, magnesium and all these, which is the largest? Rubidium. Rb plus is having least charge and highest size. So what we can say? It is going to be least covalent. So which is most covalent? Beryllium chloride, while least covalent is RbCl. So Be, okay, maybe greatest and the least. Greatest is going to be Be. And acha, ionic character. We have written covalent character. What we can say? So least ionic character and it will have highest ionic character. Think about it. So RbCl and BeCl2. Option B. Very good question. Go through it. Which among the following is a ionic compound? LiF, Li? No? Okay. Most ionic compound. Okay, think about it. Here all the cations are same. Think about anion. -1, -2, -3. Because we know that covalent character is directly proportional to charge on an ion. So what we can say? Ionic character will inversely proportional to charge on an ion. What we can say? So option, this is going to be least or most ionic. Acha, most ionic will be A, because least ionic is this, so most ionic is this. Okay, chalo aage badho. Polarization is the distortion of the shape of an anion by the cation. Which of the following statement is correct? Maximum polarization is done by a cation of high charge. Yes or no? Yes, बिल्कुल सही. तो correct है ना? ठीक है. Cation of high charge. ठीक है. The molecule having smallest bond angle. Now we have come to the bond angle part. So basically structure NCl3, AsCl3, SbCl3 and PCl5. Here comes VSEPR. VSEPR. How the VSEPR is going to be thought of? Please think about something like that. Whenever there are two cases are there, consider there is any AB2 molecule is there. AB2 molecule. AB2. I'm not talking just AB2, AB3, AB4, whatever is there. But A contains a lone pair. Just think about it. If more electronegativity of A is more than electronegativity of B here electronegativity of A is less than electronegativity of B. So what will happen? This bonded pair of electron will be more towards B, and these bonded pair electron will be more towards B. But here what will happen? Because electronegativity of A is more, so what will happen? These electrons will be more pulled towards A. What will happen? Can you see there bond pair repulsion will be very strong. Of course we know that lone pair repulsion LP is more than LP, BP is more than BP. Bond pair repulsion is least. So, but here what is happening? Because the electrons are close, so this is very much pushing outside. So this lone pair is not able to push it very much. So what we can say? So here bond angle alpha, consider here alpha and consider it is alpha 1, here alpha 2. What we can say? Alpha 1 will be high. The reason is the internal lone bond pair repulsion. Here also it is pushing it downwards, but what is happening here? This bond pair repulsion is very, very small. So what will happen? The overall trend will be inside, very high. So here alpha 2 will be less. So what we can directly say? If the central atom is more electronegative, the bond angle will be more. Simple. Think about it. Because all the side atoms are same. So think directly about the central atom. Central atom of nitrogen is maximum. Of course here bond angle will be maximum. Simple, very simple. Next, which of the following compound has the smallest bond angle in its molecule? SO2, OH2, SH2, NH3. I think this is something from hybridization directly. And VSEPR. SO2, it will be what? First of all, find out the hybridization number. Hybridization or steric number. Steric number or hybridization number, it is nothing but it is equal to number of sigma bond plus number of lone pair. It is also equals to half of V plus M minus C plus A. You can just do that and do it very fast. SO2, SO2 is nothing but sp2. You can see S has how many electrons? Valence electrons 6. Oxygen is a mono, not mono, but it is divalent. So do not count it. So sp2, steric number comes to be 3. So it is sp2. sp2 is what? It should be trigonal planar, but it will not be. The reason being is because there is one lone pair is there available. So S double bond O, and here is lone pair. What will happen? This bond angle that we are expecting to be 120, but it will become less than 120. The reason being that lone pair, that you can see, contract this bond angle. What about OH2? It is sp3. The reason being half of M, lone pairs are 2. How many of the sigma bonds are there? 2. So therefore steric number comes out to be 4. That is for sp3. What we are expecting? We are expecting 109.5 degrees. But what happens? We all know that V1OHH, lone pair just pulls the bond pair inside, VSEPR theory. So in such case, what happens? This becomes, angular. We call it angular shape. And this alpha or theta becomes less than 109.5. And we can say 104.5 degrees approximately. SH2, think about SH2. SH2 is it is a Dragos compound. What is Dragos compound? Please, very, very, very important point. We are going to study about Dragos compound. Dragos compound is those compound where hybridization does not take place, but the molecules are formed by the pure orbitals. Molecules formed by the pure orbitals. Formed by overlap of pure orbitals. Think about, and when, what are the condition? Please remember the condition. What are the conditions? Please keep in mind. First condition is that the central atom should belong to first, 15th and 16th group. Second thing, that from third or higher period. Third thing, that side atom. Now we are talking about the side atom. And one more thing, at least one lone pair should be available. Second point that you have to keep in mind, side atom should have electronegativity less than 2.5. अरे छोड़ो दुनिया भर की बातें, सीधा याद रखो. Hydrogen, side atom, if it is hydrogen that is having 2.1 electronegativity, it will be a very good example. So directly remember, if you are taking nitrogen family and oxygen family, so nitrogen family ke niche before nitrogen means phosphorus, arsenic, antimony, bismuth, all the hydrides will be Drago compound. And if you talk about oxygen family mein sulfur ke niche sulfur, selenium, tellurium, polonium, all the hydrides will be Drago compound. And what is the khasiyat? What is the speciality of Drago compound? The speciality of the Drago compound is they have that bond angle somewhere equals to 90 plus minus 5. So their bond angle decreases by very high margin. And why does it happen? Because they are making the bond by the pure orbital. And which are the pure orbital? Pure p orbital, because we know that how many of the p are there? Px, py, pz. So they all are at the 90 degrees from each other. So that's why whatever is the angle between them comes out to be 90 degrees. That's why I have written 90 plus minus 5. क्या ये बात एकदम समझ में आ रही है? Yes. So H2S will have the bond angle close to 90, and that comes out to be 93 somewhere around, right? NH3, you can see that nitrogen has how many of the lone pair? I hope you can see that one H. One lone pair cannot press the bond pair so much as it has pressed in water case, because there are two lone pairs. They are pressing very high, but they are pressing not so much because there are three bond pairs are there. What happens here? Bond angle we are expecting to be 109.5, but it is coming somewhere around 107.5 degrees or 107 degrees. What we can say? Maximum is going to be ammonia. Any dikkat, any doubt? I hope you all can see that. It is very important, very, very, very important point. Please keep in mind. And which are the molecules? I have already told you. So Drago molecules, if I say Drago compounds are going to be hydrides of of sulfur, selenium, tellurium, polonium, and phosphorus, arsenic, antimony, bismuth. So how can you see that? See H2, S, H2, Sc, H2, Te, H2, or leave it up till here only. In here P, H3, phosphine, AS, H3, arsine, Sb, H3, bismuthine. I hope, sorry, antimony, understanding it. Molecule in which the distance between the two adjacent carbon atom is largest. चलिए आइए भाई देखते हैं. जहां पे always remember, if or not if directly I'm writing few things. Bond length is inversely proportional to bond strength. One thing, the more the bond strength will be there, the lesser the bond length will be there. And one more thing, inversely proportional to bond order. But one more thing, when the constituent atoms are same, constituent atoms are same. ये मत कर देना कि atoms different है वहां पर तुम लोग compare कर रहे हो. No, never ever make it. Next, one more thing, bond length is inversely proportional to percentage S character. Percentage S character. As the percentage S, more the S percentage will be there because S is small in size compared to P and D and F. So what will happen? Their bond length also becomes smaller when the percentage S character becomes more. Next, benzene. Think about benzene. I hope you all know that. What is the bond order? Bond order comes out to be, I hope you all know that bond order comes out to be 1.5. Bond order comes out to be 1.5 due to resonance. Ethyne, C, triple bond C. Can you see? So what is the bond order? Bond order comes out to be 3. Ethene, carbon, double bond carbon, H, 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 H. What we can say? Bond order comes out to be, अरे बोलो भाई, 2. Ethane, C, C, H, 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 H. Can you see that? What we can say that? Here bond order is 1. So where it is least, where it is most, you can see that here bond order is maximum. Here bond order is maximum. So bond length is going to be minimum. So largest it is asking for. Okay, largest. So here bond order, because we know that bond length is inversely proportional to bond order, because bond order is least, bond length will be highest. So option D is the correct option. Not a big deal, easy one. हो गया कि नहीं? Next, in a series ethane, ethine and acetylene, the CH bond energy is, यार देखो हमेशा याद रखो that what we can say, CH bond energy. Yeah, पीछे तो हमने बात की ना. Here this one, bond length less, bond strength more. So here we can see that ethylene, sp2, carbon bond is sp2. Acetylene, carbon triple bond, sp. Ethane, sp3, because carbon is single bond. So what we can say, bond strength, bond order maximum, that is 3. So bond percentage, and what else is there? Percentage S character is how much? 50%. Here what is happening? sp2, percentage S character is how much? 33.33%. Here what is happening? Percentage S character is 25%. So what we can say, if sp3 has 25% S character, so what will happen? Bond length will be smallest, because it is percentage S character is maximum. Percentage S character is maximum. Just a minute. What is it? Sorry. Here percentage S character is maximum, and here percentage S character is minimum. So if percentage S character minimum, so it will be largest. It will be largest. If the percentage S character is more, so it will be shortest. Shortest. So it is asking for ethylene bond energy. If shortest is there, so it will be, strongest will be there. So bond energy will be more. Bond energy will be more. So see that. So acetylene is going to be greatest in acetylene option. Next, the correct order of CO bond strength among COs, carbonate and carbon dioxide. See that, CO. So how do you make CO? C double bond oxygen ka octet complete, but still oxygen has lone pair. Yes or no? But carbon has no lone pair and carbon has not completed its octet. What will happen? Oxygen will donate its lone pair to it. How it will looking like? It will be looking something like that, plus minus. Yes or no? Or you can say that C double bond O, oxygen is giving the lone pair to carbon. That is how it will be looking like. So what we can say, bond order is 3. Here bond order comes out to be 3. What about carbonate? C double bond O minus, because we know that it is what? It is what? sp3. It is looking like this oxygen is sp3, but because this carbon is what? sp2 hybridized. Once sp2 hybridized is, you know, adjacent to sp3, that bagal wala sp3 becomes sp2 if it can donate its lone pair. So because we know that this has the lone pair, so they will come in the resonance. Once it comes in the resonance, so all the oxygen will be looking something like that. COO. I'm not giving that much of detailed explanation. Minus of 2 by 3, minus of 2 by 3, minus of 2 by 3. This will be the charge, and this will be the bond order. Bond order comes out to be, bond order comes out to be, how many total number of bonds are there? 1, 2, 3, 4. How many of the CO bonds are there? 3. So total number of bonds 4 by total number of CO bonds, that is 1.33. So what is the bond order here? Bond order is here 1.33. In carbon dioxide, C double bond O double bond O. What is the bond order? Bond order, you can see that there are 2 bonds. So bond order is 2. So अब यहाँ पे आप खुद ही देख लो what it is asking for. Correct order of bond length, because we know that bond order is inversely proportional to bond length, because here bond order is maximum, so bond length will be minimum. So CO for minimum and CO3 carbonate for maximum. Carbonate for maximum, CO for minimum. Option A. Not a big deal. Easy one. Next. Which of the following order is not correct? NaCl, MgCl2, AlCl3 ionic character, because all the anions are same. Think about the cations. क्या cation यहाँ पर देख रहे हो? Charge is minimum. Here charge is more. Here charge is maximum. So what we can say? इधर covalent character increasing and ionic character decreasing. So of course ionic character minimum for AlCl3. तो ये तो भाई true है. Next, not correct, but it is asking. Phosphate, carbonate, sulfate, formal charge on terminal oxygen. You will have to make all those P double bond O minus, O minus, O minus. What you will see that oxygen has 3 charges, but how many of the PO bonds are there? 4. So every oxygen will ultimately get formal, all the oxygen will get formal charge, because this 3 negative will be divided into all 4 oxygen. So it will be minus 3 by 4. What about carbonate? C double bond O minus, O minus. Here it will be divided in how many of the oxygen? 2 negative is going to be divided into 3 oxygen. So formal charge will come out to be 2 by 3. That is minus of 0.66. That is minus of 0.75. What about this sulfate? Sulfate S double bond O minus, O minus. How many of the negative is there? 2. But it is going to be divided into how many oxygens? 4. So every oxygen will get formal charge equal to minus of 2 by 4, that is minus of 0.5. Of course we can see that it is minus 0.5, it is minus 0.66, it is minus 0.75. Of course it is correct. सही है. Formal charge on terminal oxygen is perfectly correct. NNPP, single bond strength. It is wrong. It is all wrong. आप बोलोगे sir why? Because we have already studied in valence bond theory कि smaller the bond will be there, stronger the bond will be there. Yes or no? Please remember one thing. According to VBT, bond strength is inversely proportional to size. बिल्कुल सही है. No problem. Bond strength is directly proportional to directional nature. That's why we see P bond is more than SP bond is more than SS bond. But make sure the size is going to be same or comparable. But for nitrogen, oxygen and sulfur, what I'm writing? For nitrogen, oxygen and fluorine, we see that because of second period element, their size is very small. So whatever is the lone pair on that, they repel each other very highly, and because of that repulsion, their bond strength becomes less. So that's why NN becomes small, less than PP. We are talking about bond strength. We are only talking about bond strength, not bond length. वो तो सबको पता है. OO is less than SS and FF is less than CL. इसलिए याद आया जब बॉन्ड डिसोसिएशन एनर्जी की बात आती है तो क्लोरीन इज मोर देन, ब्रोमीन इज मोर देन, तब आता है आपका फ्लोरीन. रिमेंबर, प्लीज कीप दिस थिंग इन माइंड. तो ऑफ कोर्स ये बिल्कुल सही बात है, नो इश्यूज. 2p क्या बॉन्ड स्ट्रेंथ की बात सही है? बिल्कुल. डायरेक्शनल नेचर इन 2p इज मोर देन 2s2p इज मोर देन 2s2s. इन सबसे भी स्ट्रॉन्ग कौन हो गया? 1s, क्योंकि यहाँ पे साइज क्या हो गया? छोटा. प्लीज कीप इन माइंड. अब ये सब चीजें जितना जानो उतना अच्छा है, ठीक है. नेक्स्ट, which of the following is not isostructural with SiCl4? You can see that it is sp sp3 can you see sp3 and the same can you see it is sp3 हाँ भाई कर लेना तुम 5 plus 4 minus 1 5 plus 4 9 9 minus 1 8 half of 8 is 4 sp3 बिल्कुल सही है क्या ये आपको दिख रहा है तो आइसोस्ट्रक्चरल नॉट आइसोस्ट्रक्चर अच्छा नॉट आइसोस्ट्रक्चर SCl4 S is what 6 plus 4 sp3d of course it is going to be the correct option. All right, how it will be looking like? It will be looking something like that. S because one lone pair there it will be there on the equatorial position, not on the axial position. It will be looking like seesaw. So option B is the correct option. Next, in which of the following pairs the two species are isostructural? BrO3 minus and XCO3 minus. Find out कर लो. बिल्कुल सही बात है. ये भी आपका क्या हो जाएगा? sp3 and tetrahedral. It will also be sp3 and it will also be sorry, but it is not tetrahedral. Basically, it will be O3. It will be pyramidal, trigonal, pyramidal, and it will also be trigonal, pyramidal. ये तो सही है भाई. SF4, XCF4. SF4 की बात करो, it is sp3d, while here it will be sp3d2. Of course, I hope you can see that. It is going to be something like seesaw, but it is going to be XCF4. Find out करके देख लेना. Square planar. Yes, that whisper वाला पूरा हम लोग देखते हैं ना. It is what? AB4 and two lone pair, AB4L2, while here it is what? AB4L, one lone pair. Yes or no? Next, आगे बढ़ो. Which of the following species do not exist? चलो हमेशा existence और non existence वाले क्वेश्चन के बारे में एक बात हमेशा याद रखो कि whenever there is small, if there is any second period element that can never have more coordination number and covalency more than 4, so boron can never have 6, so it is not exist, do not exist. So option A correct option. बात ही खत्म. आगे बढ़ जाओ. Next, which of the following planar exist? Planar species. BCl3, SF4 no, CH4 no. Check कर लेना. Among the following molecule, those having same number of lone pair on xenon. Xenon पे कितना lone pair? Xenon has how many of the valence electrons? 8. How many of the oxygen are there? 3. Every oxygen makes how many bonds? 2. So 2. 6 electron is already taken. How many remaining? 2. XCO4. One oxygen is taking 2 electron. One fluorine is taking 1 because fluorine is monovalent. So how many taken? 6. How many remaining? 1. XCF4. How many it has? 8. How many bonds it is forming? 4. How many still remaining? 4 electron. 4 electron remains for 2 lone pair. So what we can say? No, it is different. 1 and 2. 1 and 2 only. Option 1. Shape of SF4 and XCF2 respectively are. SF4 is SC. It is seesaw. Well, it is what? It is. Can you just find out? sp3d. sp3d, that is AB2L3. 3 lone pairs are there. AB2L3. So how it looks like? It looks something like that. AXC. And all the lone pairs will be on the equatorial position, but fluorine will be on the axial position. It is what? It is called Bend's rule. Bend's rule says that if there is more electronegative element, it will always be on the axial position, never on the equatorial position. The reason being, equatorial positions are, smaller and their electronegativity is high. If there is any position where the electronegativity is high, more electronegative element will never come there. So because these equatorial positions are smaller in size and their electronegativity is high, fluorine will never take that place. Fluorine will always go for those positions if it is possible, if availability is there, for those positions where there is electronegativity less or percentage S character is less. So यहाँ पे percentage S character is less, so fluorine occupies the axial position, not the equatorial position. So what we can say, this is linear and this is what? Seesaw linear. Option B. Next, which of the following statement is incorrect? Dipolar moment of CH3Cl is greater than CH3F. बिल्कुल सही बात है. अब आप बोलोगे सर यहाँ पे electronegativity इसकी कम है, इसकी ज्यादा है, क्यों? Always remember CH3Cl is going to be more than CH3F due to, because mu equals to Q into D. यहाँ पे distance is very, or you can say bond length is more, यहाँ पे bond length is very less, that's why. तो क्या पूछा है? Incorrect. अच्छा ये तो सही बात है. ICl2 minus is linear shape. Yes, you can just find out. It will be again coming sp3d and again it will be AB2L3. check कर लेना, AB2L3 में linear shape होगा. XCF2 has 2 lone pair of electron. No, it will have 3 lone pairs. No, 3. So option C is the correct option. Next, in which of the following molecules or ions all the bonds are not equal? SF4, can you see SF4? What is that? It is sp3d. You can find out. 6 plus 4 is 10. Half of 10 is S5. Steric number 5 for sp3d. So it should be what? SF F, F, F. What we can say that lone pair will always take the equatorial position, never the axial position if it is possible. So what we can say in this case, can you see if these are axial while these are equatorial bonds. So what we can say, molecules, all the bonds are not same for sure. यहाँ पे these two are equatorial, but these are axial. So these will be, and we know that in sp3d length of axial is more than length of equatorial bonds. Please keep in mind. So option A is the correct option. Next, आगे बढ़ जाओ सीधा, easy है. In ClF3 the lone pair are present at approx. Okay, let's talk about what is the hybridization. Steric number comes out to be 5. So therefore it will be sp3d. अरे यार तुम लोग कर लेना. Cl has 7 plus 3 10 का half 5 sp3d. So Cl again, how many of the lone pair will be there? 2 lone pair are remaining. 2 lone pairs are remaining. Where they will remain? They will remain on the equatorial positions. लो भाई, equatorial positions पे there are lone pair F, F, and there is F. Can you see it is T-shaped? T-shaped में what it is asking for? It is asking for lone pair are present at 120 degrees. Option B is the correct option. Easy one. Next, the maximum number of 90-degree angle between the bond pair electron is observed in. जाके check कर लेना. It is going to be octahedral. That is sp3d2, sp3d2, d2 sp3, d2 sp3 or sp3d2. Both of them are same. Please, you can just do that. How can we say that? चलो भाई दिखाई देता हूँ यार, ऐसी क्या बात है. आ जाओ देख लो. See, how many of them are there? 1 2 3 4. 4 तो ये हो गया in the plane. Can you see? ये जो above the plane, एक protrusion is above the plane, one protrusion is below the plane. Let's say this is square planar, one is protruded upside, one is protruded downside. So this protrusion is going to have, 1 2 3 4. How many of the bonds are there? There are 4 bonds. So 4 के साथ 90, नीचे वाला भी 4 के साथ 90, नीचे भी 4, ऊपर भी 4, बीच में भी 4. So overall, how many of the 90-degree angles are there? 12 are there. Nobody will have the 12. You can see that D2sp3, that is octahedral structure. In octahedral structure, maximum number of 90 degrees are there. The strength of covalent is directly proportional to, is dependent. Of course, it is dependent, bhai. Of course, no doubt about it. Next, lone pair of phosphine occupies. Lone pair of phosphine. Phosphine is Drago compound. It is Drago compound. Whenever there is Drago compound, please be very much careful and cautious. So P, H, 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 because we know that all the hydrogen bonds are there. It is from the p orbital. So px, py, pz is already used. So phosphorus has one lone pair. Where this lone pair will be there? It will be in the pure s orbital, because all these are px, py, and pz orbital. And hydrogen, so I hope you all know that 1s. Arey, easy hai bhai. It's or no? Next, come to the spherical s orbital, almost pure orbital. Of course, it is correct. Next, which of the following has tetrahedral structure? XCF4, no. H3PO4. Always remember, all the oxy acids of phosphorus are going to have the yes, hybridization sp3 as a rule. जाओ भाई, use कर लो जहां मानो. All the oxy acids of phosphorus are going to have the hybridization sp3. All the oxides of phosphorus are going to have, the central atom is going to have the hybridization sp3. In which one of the following sp3 species the central atom has the type of hybridization which is not same as that of present in the other 3? Okay, PCl5 sp3d, SF4 sp3d, I3 minus 7, just a minute, what is that? 7 7 plus 1 sp3d. How it is? Just do the same thing. One iodine will be having central atom. Let's say one central iodine is there, 7. How much of the negative is there? 1. So 7 plus 1, how much? 8. And 2 iodine will be there side. So 1 1, because iodine is monovalent. So how much is there? 10. Half of 10 is what? I hope you all understand it. SbCl5. Sb is how much? 5. Plus chlorine is coming 5. Plus how much of negative is there? So how much it is? sp3d2. So option D is the correct. All others are sp3d. In which of the following pairs of the molecules ions the central atom have sp2 hybridization? BF through, array bilkul sahi. NH2 minus nitrogen being 5. 5 plus 1, 6. Hydrogen 2 और आ गए. 6 plus 2, no. It is to sp2, but it is not. It is sp3. It is sp3. NO2 minus, yes, of course it is sp2. NH3, no, it is sp3. BF3, yes, sp2. NO2 minus sp2. Option C is the correct one. Go and check half of V plus M minus C plus A. Do it, very easy. Now, in which of the following molecules the central atom does not have sp3 hybridization? SF4, no. sp3d. It is what? sp3 does not have sp3. Acha, option A. Next. Number of pi bonds and sigma bonds. I hope you all know that how to find out pi and sigma. First of all, you are going to find out all the sigmas. Though it is not given, you can make it. How many are there? One. I'm starting from here. How many sigma? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Huh? How much is this? And 19. So how many? 19 sigma is there. Option to yahin se aa gaya. How many pi are there? 1, 2, 3, 4, 5. 5 and 19 option. This. According to VBT, which of the following overlapping result in pi type of covalent bond in O2 molecular formation of when Z axis is internuclear axis? Always remember, pi is not due to the end to end. It is due to the collateral overlapping. Collateral overlapping. If the Z axis is the internuclear axis, collateral will be towards X or Y, or lateral it will be 2px, 2px and 2py, 2py. That is 2 and 4 is the correct option. Others are no. It will be forming sigma. It will also be forming sigma because S can only form sigma. S can never form pi. This is also going to be sigma. Why? Because towards pz it will be end to end. Which of the following p pi d pi bonding? NO3 nitrogen is from second period. Second period में होता है क्या p? नहीं. Oxygen is also from second period. क्या होगा क्या? नहीं. 2p pi होगा. SO3 में क्या हो जाएगा? Of course it is possible. In all other you can see the second period, second period, second period, second period, but here it is possible because sulfur is from the third period element. So here D is possible, of course. See, ये p pi d pi find out करने का पूरा way होता है. We could do it, but here because of the lack of time we cannot. Which of the following pair of species have same hybridization but different bond angle? BF3, BCl3, and all these things are there. Okay. I will just take these things, hybridization related questions. I'll leave. You can just see these questions. Do it easily because we have solved almost all the types of questions. Because I have to go for the MOT, molecular orbital theory. I want to go for the molecular orbital theory. Let's see. Maximum number of percentages character, easy ones. We have come to that. Please, molecular orbital theory ke liye, please remember few things. Molecular orbital theory. Very important thing for molecular orbital theory is one of the very important questions comes from there. What we have to do? We have to remember few of the things, that if there is number of electron less than 14, what you are going to do? How the electron is going to be formed? It is going to be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. यहाँ पे फिर what will happen? Pi 2px equals to pi 2py, then sigma 2pz, then pi star 2px equals to pi star 2py, then comes out to be sigma star 2pz. That is how, and what is that rule? Will be Hund's rule will only be followed MO2T less than 14 electron species, and that too for in your syllabus only. Here what is happening? SP mixing is taking place. That's why this is the SP mixing is there. But when there is more than 14 electron and less than or 14 it equal to. But when it is more than 14 electron species there, how it is going to be there? It is going to be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then it is going to be sigma 2pz. See, here there is change. Sigma 2pz was above. Here pi will become up. Pi 2px equals to pi 2py. Use always Hund's rule. Never ever break the Hund's rule to do that. Pi star 2px equals to pi star 2py. And last में होगा sigma star 2pz. So please follow these things. Next, we are going to talk about few rules or few direct things. If bond order is equals to number of bonding electron minus number of anti-bonding electron divided by 2, bond length is inversely proportional to bond order. Bond strength is directly proportional to bond order. That is also directly proportional to bond energy. These things I hope you all understand. Bond order or bond strength is inversely proportional to number of anti-bonding electron. Number of anti-bonding electron. This one. Number of anti-bonding जितना ज़्यादा होगा bond strength उतना ही कम होगा. That is these are the few rules. Always remember few of more things you can find out or directly rules are there. B2 have only one pi bond, no sigma. C2 has two pi bond, no sigma. So according to VBT, always there should be first sigma and then pi bond will be formed. But MOT told no, first pi bond can also be formed. And these are the few examples. Please keep in mind, there are very important, the beautiful examples. इसका लिए bond order is 2. इसके लिए bond order equals to 1. Then comes for O2, that is 16 electron, and B2, that is 10 electron. They being, even if they are, you know, even electron species, still they are magnetic species. Please remember, even though they are even electron species, still they have the they are paramagnetic species. In all other case, other even electron species are going to be diamagnetic. Can you remember all these rules? And then there are more few things. Please keep in mind. Number of electrons and bond order. I'm writing it down. If there is 1, 2, 3, 4, 5, 6, 7, 8. So for 1, bond order will be 0.5. For 2, it will be 1. 3 के लिए 0.5. 4 के लिए it will be 0. So it will be non-existent. Because bond order is 0 means exist नहीं कर रहा है. It will be 0.5. It will be 1. It will be 0.5. And 8 के लिए it will become again 0. That is non-existent. Example क्या है? BE2. BE2, 4 plus 4, 8. It will be non-existent. It is what? He2. Helium. 2 plus 2, 4. Non-existent. Okay. Next come directly to 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. These, please keep in mind. Rule क्या है? Start from 0.5, 1, make increase up to 3, 0.5, 0.5. It will become 1.5, 2, 2.5, 3. Then again decrease 2.5, 2, 1.5, then 1, then 0.5, and ultimately as it comes 0, 20, that is Ne2. It is also going to be non-existent because it is 0. So non-existent. Any issue? I think there is no issue. According to molecular orbital theory, which of the following is correct? LUMO for C2 is molecule is sigma 2p. Please just go with that. LUMO is nothing but lowest unoccupied molecular orbital. C2 means less than 14. So which you will follow here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see? It is HOMO. It is what? HOMO. That is highest occupied molecular orbital. What is LUMO? It is LUMO. LUMO is something that is lowest unoccupied molecular orbital. So it is sigma 2pz. Yes or no? Sigma 2p. Yes. Is it given? Sigma 2pz. Yes. So this is to correct. In C2 molecule, both the bonds are pi bonds. अभी मैंने बताया B2 और C2 में both of them are pi. In C2 there is both of the pi. In B2 only pi. In C2 minus there is only one sigma and 2 pi. Only one. Yes, it is also correct. Option D. You can go with that. Very important. Whatever the MOT I have told you, just go through it. SP mixing is opera only less than or equal to 14. Okay. Oxygen में O2 में no. It will not be seen. Which of the molecules out of the following does not contain unpaired electron? You can see it is odd electron species. Odd electron species, of course, it will contain. It will also, because it is O2, that is 16 electron species. 16 electron species also contains. Not follow. So O2, it is what? 18 electron. Of course, it will not follow. Next, in which of the following process the value of the magnetic moment does not change? N2, that is 14. 14 to, it is what? 16. ये हो जाएगा because it will be paramagnetic. It is diamagnetic. 14 is for diamagnetic. 16, that is I told you. O2 was also para. It will also be para. Can you see B2 is para? I told you. Though it is 10, still it is. It will be 12. So it will be dia. No, it is changing para to dia. O2 plus it is 15. O2 minus 17. It is what? Para. It is also para. Why? Odd electron, odd electron. Para to para means no change in magnetic character. Correct order of bond length. Okay, bond length is inversely proportional to bond order, can you see सबसे ज़्यादा bond order O2 will have how much? 2. O2 plus 2.5, O2 minus 1.5. So bond order of course is going to be maximum for O2 minus 2 and minimum for O2 plus 2. Option B. Easy है, ठीक है? Which of the following has only pi bonds? N2 no, B2 yes, C2 both B and C. If bond order of NO is 2.5 while NO plus is 3, which of the following statement is true for these species? Bond length is, अरे आप देख सकते हो और please कर सकते हो. Bond order bond length relation, everyone we know that. Which of the following species does not exist under normal condition? D2, everyone, because 8 electrons are there. 8 electron is non-existing species. Total number of anti-bonding electron presence in O2, you can see that, you can find out it is going to be 6 because bond order comes out to be how much? 2. That is how much? 10 minus 6 divided by 2. That will be 2, of course. So it is non-bonding, sorry, bonding, it is anti-bonding and it will be bonding. So next, which of the following molecules or ion does not contain unpaired electron? You can see that it is not going to have any. Paramagnetic, whenever it is talking about, so use MO2. All of these are depending on MOT. Just use MOT on get the answer. Next, what is the dominant intermolecular force that is between CH3COH when it converts from liquid to gas? It is hydrogen bonding. Hydrogen bonding, option B. In which of the following substance will hydrogen bond be strongest? H2O, because electronegativity difference पे depend करता है. The strongest will be HF, then OH, and then NH, and then that is how, because hydrogen bonding only forms in FON, fluorine, oxygen, and nitrogen. Now, assuming the Hund's rule violation, okay, B2 molecule. Acha, the bond order and magnetic nature of the B2. B2 means 10 electron, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we can say, 10 electron because it is breaking the Hund's rule. So if it was not breaking Hund's rule, what will happen? It will be like that. But it is breaking Hund's rule, what will happen? 10 electrons here only. So it is going to be, because electrons are paired, so therefore it is diamagnetic and it is sigma star, it is sigma star, sigma, sigma. Bonding will be how much? 2, 2, 2. 6 minus 4 divided by 2. That is how much? 1. So 1 and diamagnetic. 1 and diamagnetic is yes, option 1. These are the questions. I hope you can do that. Not a big deal. The maximum number of possible number of hydrogen bonding in the water molecule is going to be 4. Always remember. So which of the following is paramagnetic? We have already seen that. You can see whenever is odd electron species will be there, it will be paramagnetic. You can see that it is going to be 17 electron. So this is paramagnetic. Not a big deal. Others will be not. According to MO3, I hope you all can do that. Okay? O2 plus is what? It is 15, while O2 is 16. So it has 2.5 bond order. O2 has 16. So paramagnetic and bond order is greater than O2. Of course, it is correct. Next. So which of the following does not have the hydrogen bonding? Phenol has liquid nitrogen, ammonia has, water has, HCl does not have. Next. Okay, so that is all for this chemical bonding. It was a very long chapter. We have tried to take all the types of question. So what are the important points? We have already covered, like whisper, MOT, VBT, hybridization, and Fajans rule. If you just do the question from here, almost 90% of the question are fixed from here. Today, whatever the type of question we have solved, please go through it. And all the best for the preparation. Thank you. That